Senior Product Manager here at SAE International. And joining me today is Uxue Zurutuza. She is a Senior Data Scientist at Cognistx. We have partnered with Cognistx to digitize our standards using a machine learning model. So what we're here to talk to you about today is how to write standards in a way that makes it easier for machines to read your standards in addition to having humans read your standards. So let's get started because we've got a lot of material to cover in just an hour. So it's very important for standards authors to start changing how they think about writing standards. Today, when someone sits down to write a standard, they're thinking, I'm writing a document, just like I'm writing a Word document or a Google document or such. But a document is very different from a digital standard. You need to think about how that document is going to be broken up, and each requirement in different parts of the standard are going to be extracted, and they need to stand on their own in a way that they don't stand on their own when you've got the context of the entire document. This can impact sentence structure. It can impact how you have your tables organized. It can impact variable naming and all sorts of things. So it's very important to rethink how you're writing standards so that they can be in a better format to digitize using these types of natural language processing models. So when you think about standards, you need to realize a standard does, a PDF is how we generally distribute standards today, but a PDF is very, very different from a database. We're going to have to start thinking about documents and standards as being more pieces, several different components of a database that are going to be separated and need to stand on their own. Another thing to consider with digital standards is how they're going to be searched and used very differently from how PDF standards are used today. Imagine a design engineer and they're going to work on a design for something and they want to search for a part, or they want to look for a material that's going to meet the requirements of their design. It might be a bolt of a certain length. It might be it has to have certain tensile properties or certain heat tolerance. However, they're going to be wanting to search for things that meet those criteria. So they're going to be searching on dimensions, on elemental composition and properties in ways that you can't search groups of PDFs today. So it's very different for how they're going to be used, and that also will impact how your standards are written going forward. And when you think about, these natural language processing models have some limitations. So you have to think, if you structure your standards in a way to make them easier to digitize, it's going to drastically reduce the cost of that effort and the time it takes. So that's really what we're trying to share with you today. We've digitized about 1,000 standards, primarily metals, bolts, and nuts. And we've learned a lot of lessons that we want to share with you on things about how to structure your tables, about things you need to be aware of with drawings and variables within standards, about how to structure content and how to structure your document itself. So Uxue and I are going to go through each of these, and we've got a lot of examples and such that we're going to share to help guide you and how you can think about standards differently, think about how you're writing them differently, and start writing standards in a format that will make it easier for you to use machine learning models to digitize your standards. Ultimately, we want to have a tool that we can write a standard and write it in digital form and in PDF form all at once, but we're not there yet. So in the interim, these types of machine learning models are the best way to digitize your standards. And it's important for you to realize things you can do to make that process easier, to make it more less prone to error, and to make it much less costly for your organization. So we're going to start with table structure. Table structure can, when you think about it in terms of how risky is it if your table structure is digital ready or not, it's really a high risk because your tables contain data, and they often contain data that you need to reference in some way. So it's very important to think about how you're structuring tables. From a very basic level, you need to think about what are you putting in your column headings versus what do you have in your rows. I've used the example of property tables here. We found that it's much better approach to organize your property tables with your properties as column headings as opposed to having them in the rows. It helps to extract that information much easier. And if you do this consistently, your model will come to recognize this is a property table, this is how it's organized, and this is how I need to pull the data, and this is how I interpret it. And it makes it much easier than if there's different ways you have your property tables organized. You can, I've actually shown 2 examples of ways you could do this. You can still have it all in one table, show different units of measure within the same cell, or you can you can show the tangential and the axial all in one, or you can separate it and just have one value in one table for your tangential and one for your axial. Either way works. What you want to strive for with tables is to try to get one data value per cell. Move on here. So here's another example. I've got a few examples of property tables. This one kind of struck out to me because it made me realize that in some cases, you may want to split things out into multiple columns. If you'll see, the original table has the hardness values all in one column, but technically those are different data values that might be searched in different ways. You might want to search for a material with a certain hardness measured by HR15N versus HRC. So separating these out into separate data columns is the best way to organize this table, even though you have some cells that have no data values. It's important to make sure that you've got each of those so that when someone goes to search them, they are searching for a specific variable. And organizing the table this way will have a set of hardness for each of these types of ways you can measure hardness. Some more examples of property tables are here. As you'll see, especially in the table on the bottom left, it's almost like 2 tables were merged into one for this one. And it's really best to keep your tables as simple as possible. And I'll be reiterating this later also. But spreading this out, making sure, again, striving so that you have one data value where possible in each cell. You could even, in this example for table 2, you could even take it a step further, and for the nominal diameter column, split those each into 2 columns. So you'd have a minimum column and a maximum column. It is still, you can have your model interpret ranges that are within a cell this way, but that really is the best practice to make sure that each data value is completely clear what it is to separate those out and strive to have one data value per cell. I think it's also important to realize that you may need to split a table into multiple tables in order to simplify it. In this example here, we split out the type 1 and type 2 in a separate table from type 2 and from type 3, so that we can break out the min and max for each of those values. So you're striving for that simplicity. You're striving for that one data value per column to make your tables as easy to interpret as possible. I've included several examples here of different tables that are good tables. You'll see in general, they each have about, in most cases, they have one value per cell. The bending parameters does have two, but at least it's a clearer that it's a range and it's defined how it is a range. The model seems to handle it easier when, the same value is in different units of measure, but really if it's a discrete separate value, a discrete separate variable, it's best to split those out. So this just gives you a wide range of examples that are for the most part pretty good. I love to share this table with people and really break it down because I think it really highlights a lot of things about how humans read versus how machines read. Humans have a lot of cognitive biases in terms of how we read something. We look at something and we've got this wealth of experience and knowledge that we're building it on. So when we look at this table, we can determine that in the tensile strength column, you've got two numbers. One is in parentheses, and the number in parentheses is a different unit of measure. And we can tell the difference between that and the reduction of area column, where you also have a number in parentheses, but it's referring to a note at the bottom of the table. But how is a machine supposed to understand when you're using parentheses to denote a different unit of measure versus when you're using parentheses to denote something like a note? You're using the same kind of grammatical and punctuation and style elements for two completely different purposes. And that can be just more difficult for a machine to interpret. Another challenge with this table is, again, we've got some data ranges within the columns. It would be best to split those out in the hardness column. So you have a min hardness HB and a max hardness HB, same with the HRC values. And then we get to the last column in this table where there's a lot of stuff going on. You've got multiple numbers, some in parentheses that are different units of measure, some in parentheses that are notes, and then you've got a slash, and it's like, what is this slash? I've never seen this slash before. What does that mean? And different values all crammed into that one data cell. That makes it really hard for a machine to interpret and understand how to break that out and how to have that represented in a data model. Another challenge with this table is you've got this last row that's solution heat treated, which is totally different from all the rows above it. It doesn't have data values in all the columns. When it does have data values in the columns, they're very different from the ones above it. There's not a range for hardness of HB. There's not a range for hardness of HRC when there is above. And you don't have all the data values for temperature and time. So it would be best to split that out because as a machine it would be even more unclear as how to interpret that last row since it's so different from the rows above it. So a lot of what we're going to be reiterating, not just with tables, but with other things as well, will have to do with simplicity and consistency. If I had to say that there were two main themes to this entire webinar, those would be the themes, and understanding how we read things and understanding how we interpret things and how that can be different from how a machine interprets things is really critical when we start thinking about how we want to write standards in a way to make them easier to digitize without a lot of manual oversight and manual review. So the takeaways from this section, again, simplicity. Try to strive to have one data element per cell when you're working with your column or with your tables. Think about the table structure. Think about what you're putting in rows, what you're putting in columns. If you have tables that are the same in multiple standards, like, for example, with properties tables, keep them consistent from standard to standard so that they They can be interpreted the exact same way by your machine learning algorithms. Simplify your tables, even if that requires splitting complex tables into more than one table, or if you have to repeat some data within the table. In the long run, it will be much better and ensure that your data models are interpreting and digitizing the data from these tables properly. At this point, I'm going to pass it off to Uxue, and she's going to be talking about drawings and variables.
So yeah, as Leslie mentioned, digital standards must be searchable in a different way than PDFs are. So for instance, as she was mentioning, users might want to search and compare parts based on dimensions to find the right part that they are looking for. For example, a design engineer might want to find a ball number with a given length limit, for instance. For that, it is required to have consistent dimension names in order to provide accurate results, and otherwise manual approaches need to be used to standardize dimension names. At least standards under one type and subtype have to be consistent and use the same diagram as reference, as seen in this table. This means that, for example, DBK should be referencing the same measure in the diagram or dimension across all standards that are self-locking nuts. If this is not accomplished, which is the case for a lot of part standards, it will have to be done manually, as I was saying, for example, through generating mapping files. These files will be based on a complete part diagram per subtype and will indicate what is the dimension name used in each standard versus the reference diagram. And this image represents one of the dimension files. So all the map variables are listed over there. Those are the dimensions present in the diagram. And then we will have the mapping of those dimensions in each standard. So in this case, we can see how L was referenced in the standard as L as well, but in the case of N and M, they were referenced as G and K instead. So we need to create that mapping so that we are able to compare the same things and search accordingly. And as you can imagine, this adds a lot of manual effort and complexity and could also introduce a lot of human errors. So if we are consistent throughout all standards, this can be avoided and we can stop using mapping files. But if we use different dimension names throughout the standards, then we need to introduce mapping files. In addition to this, it is pretty common to also find dimension values in standards that are not in tables, but they directly inputted in the diagram. And these are usually fixed values for the part numbers in a given standard. And extracting this from the diagrams directly and accurately is a really challenging task for machines. Therefore, it is usually even better to do it completely manually, which also, again, adds a lot of effort. And this is, in our case, added to the mapping files, as you can see in the example. One simple recommendation here will be to create one simple table with these fixed values. The headers will be the name of these dimensions, and then you will just have one row with all those fixed values. And that way we will be able to easily extract that information and then extrapolate it to each of the part numbers and duplicate that information in all the part numbers. To summarize this section, a few takeaways. It will be to use standard variables to reduce manual effort and management of mapping mechanisms of cross-standard search. Also to have relevant data in standards and preferably in tables. And also avoid using complex logic to represent any values that will leave a lot of information in the way. And lastly, to use consistent naming convention across all standards. And I think this is one of the most important advice, to use the same naming convention under at least the same subtype so we can standardize the content.
Thank you. So I'm going to jump in again and talk to you about content. So from a content perspective, when you think about the risk associated with not having your standards in a digital ready format, it's a medium to high risk if you've got some challenges here. So the theme to this section is going to be consistency. Consistency, consistency, consistency. I'm going to say it so much, you're probably going to get tired of hearing it, but that is really what this is all about. As many of you, most of you, in fact, all of you on this call should know that mm and millimeters both equals the same thing, whether it's spelled out or you're using an abbreviation. But you have to teach a machine that. Some of these things are not always apparent. So it's very important wherever possible to be consistent. If you want to use abbreviations, always use abbreviations or at least define them. It's just very challenging when they're inconsistent. Sometimes it's spelled out, sometimes it's not. Same thing when you think about properties and elements and units of measure and various other things. I use the example here of a property for arbor diameter. Sometimes it's at arbor diameter, sometimes it's at arbor diameter millimeters. This is another example where we had to use mapping files, mapping tables, to map all the different ways that arbor diameter might appear in the text of the standards and map them all to the same key value. Same thing with these elements. We found that aluminum, for example, was referenced in different ways, sometimes in the same standard and definitely across standards. So having to use these mapping files so that the model can understand what these all equate to. So inconsistency can result in a lot more manual entry of requirements as opposed to getting them extracted automatically, a lot more manual review and overhead, and all that equates to cost. So understanding that these things that we understand are all the same are not always clear when a machine is reading these standards. Another thing that we've noticed in the SAE standards, and you may notice in some of the other standards you use, is sometimes material standards have a composition table, and sometimes they don't have a table and the composition is kind of buried in the title. We really feel it's a best practice for materials to always have their composition broken out explicitly in a table and have it be very clear so the model interprets each one of these materials the same way. If it has to break out some using information how it's listed in the title and others in the table, it can just introduce opportunities for misinterpretation of the data. So having those composition tables clearly laid out is important. Data ranges. So I don't know about your standards, but I found all kinds of ways that data ranges were shown in various tables. And I probably haven't even uncovered all of the different ways across the standards, but there are some examples of what I uncovered so far. Sometimes it'll just say a number to a number. Sometimes it'll use the comma INCL to show that it's inclusive. Sometimes it has comma EXCL to show it's exclusive. Sometimes it uses phrases like and over or up to or under. Just a lot of inconsistency in data ranges and how they're depicted. I'm not saying that one of these ways is better than another, but what you need to do is strive to have data ranges documented in a consistent way so that the model has one way to interpret it instead of having complexity built into the model so it can interpret the 10 or so different ways that data ranges can be written in a standard. So this is just yet another example of how important consistency is. So pick a way and have that be your way. Make it part of your style guide and make sure that people understand that this is how data ranges should be documented. Units of measure is another area where I saw inconsistency. Looking at tensile strength, for example, some standards communicate tensile strength in PSI, and some standards communicate tensile strength in KSI. But when you search for a material, you're just searching for tensile strength. So if you have these documented in different ways, different levels of that units of measure, it just makes it more challenging because then the model has to convert all those to one because you're searching tensile strength, period. And you don't really care if the actual PDF documented that tensile strength in KSI or PSI. You're looking for a particular value. And so it's important. It just reduces the amount of conversion your model has to do if it's reported consistently. I also noticed the same thing with time, and there's probably other examples as well, but I thought these were pretty simple. You know, time, sometimes it's reported in minutes, sometimes it's reported in hours. It's the same with the data ranges. It's not that one way is better than the other, but you need to be consistent and you need to standardize on one way that you want to communicate units and go with that and make it sure it's consistent within the standard and from standard to standard. Another thing is, you know, our standards are written by people from all over the world. Some of the authors are, you know, Americans, some are from France, you know, there's just from all over the world, Europe, Asia, South America. And even though they're all written in English, there's different spellings for some things, whether you're using American English versus UK English. And I found this example of millimeters. You know, millimeters can be spelled differently. When you also think number formats are often different. You know, in the US, we tend to 1,000 is 1,000. Where in Europe, 1,000 is 1,000. So, yeah, how's a machine supposed to know if 1.000 is 1,000 or 1? And that's a big difference. So making sure it's consistent is really the key here. Again, not saying use one way or another, but pick a way and make it consistent across all your standards. Another thing common in many of our standards is using a calculation as a data value or using a word as a data value. And some examples I found are in this table 1. The value for iron is the remainder of what's left after you subtract all the others out. The value for columbium is 10 times the value of carbon in the table on the bottom. When you think about how users are going to search for materials by composition, they're going to search for materials that have a certain amount of iron or have a certain amount of columbium, for example. Remainder, they can't search on remainder, and they can't search on 10 times the value of carbon. They're going to be searching for a number. So it's best wherever possible to use numbers in your tables and not these calculations and not these words that are basically calculations or referring to calculations. You want to, if you do not do this, then the model has to calculate these. And that again, introduces areas where they could be incorrect and so forth. So wherever possible, have data values in your data tables and not calculations. Another thing to be aware of, it's not quite as difficult for your model to understand, but using consistent decimal precision makes it easier for the model. In the table below, you can see that there are some that are 3 levels of precision and others that are 2 levels of precision. It's best to keep that consistent. I think as a human, sometimes it's easier to read when it's consistent too, but it's not as big of a challenge as the actual calculations embedded in tables, but it is still something to be aware of. So I also noticed many of our standards have a mixture of fractions and decimals. I try to find a better example than this one because I know that when people think of tubes, they think of a 1/4-inch tube. And it's, you know, as 1/4 or a 1/2-inch tube as 1/2. Like those are what you see. That's what you're used to, at least in the States, when you're thinking of the size of a tube being by an inch. But wherever possible, you should use decimals over fractions. The decimals are what are typically what your data values are. And whenever you use fractions, then your model needs to understand the context of how those fractions are used. Should they leave them as fractions or should they convert them? Should they take 1/4 and convert it to 0.25? It just makes it more confusing. So avoid fractions wherever possible and use the decimal values. But I do understand that you've got to make the trade-off between how easy is it for a human to read and how easy is it for a machine to read. And this is one of those situations. So minimizing as much as possible is the way to go. Also avoiding scientific notations, things like that, wherever possible. It just makes it's more overhead, more complexity to your model when you're not using just a straight decimal number. And it also introduces more areas where you might have to manually enter the data or have extra scrutiny on some data tables that could have been interpreted incorrectly. So as I mentioned, the takeaways here are all about consistency. Every example we have shown you in this in the slide deck, and we'll continue to show you in the slide deck, we were able to digitize all of this, but it cost a lot more, and we've got a much more complex machine learning model than we would have needed if we'd known these things up front and been aware of these lessons up front. Simpler models mean less manual extraction, less manual verification, less management of these mapping tables we've talked about, more thorough search functionality, but most importantly, it's a lot less cost to digitizing your standards than it would be if you're encountering these challenges all the time. So consistency is very key. Explicitly calling out composition tables rather than having it embedded in either the title or the text of the standard. Avoid having the model have to do any calculations based on using inconsistent unit measures or things like I was talking about with remainder or 10 times C. Just avoid that wherever possible, and avoid using fractions or scientific notations unless it's really necessary for a human to understand that requirement. And I'm going to pass it off again to Uxue to talk about document structure.
Yes, so this last section is about maintaining certain overall good practices at the time of creating a structure and generating content. So one example would be to follow good practices at the time of redacting textual content and having full sentences. This might seem like a super simple, irrelevant advice, but as you can see, a lot of requirements or sentences are not even complete. Like this statement shall be as seen in table 4. That doesn't have complete meaning without the section title in this case. So we should avoid doing this type of things because, as Leslie mentioned before, we need to try to have the way we digitize is by splitting information into more granular pieces or entities. So those pieces need to have full meaning by themselves. And here the recommendation will be on the right to just repeat the information in the sentence so that that requirement will have complete meaning by itself. For a similar reason, also, like requirements should not really go in section titles, as we can see in the section in the example below. They should go in the paragraph so that we can identify them correctly, split them, and have them stored in a database correctly. In the case of tables and figures as well, what we have seen is that not always they have like table titles and references, and this actually will limit a lot the co-referencing from one section to the table or from one requirement to the table or figure. And also this information is used at the time of classifying this table and understanding the content. So having this information in place is really important. And lastly, and probably a lot of you have also similar issues or cases with part standards. Like some part standards can sometimes have written logic about how the part number should be generated, which really difficults the standardization or data extraction, tabular data extraction in this case. Because the way we are organizing the information for parts is you have a part number and all the dimensions related to that part so that it's searchable and comparable. So guidelines here in order of preference on how to handle this will be to, first of all, try to have the part number always explicitly stated in the tables with all the dimension name next to it. And if this is not possible and the tables can get a little bit long, then you can potentially have splitted tables and have clear logic on how you should be creating that part number by, for example, combining two different column names. And the last option will be to, if even the logic is a little bit more complex, to have it stated and mainly have that logic to be standard and consistent throughout all the parts under at least one subtype or a group of parts so that we can auto-generate that information. So to wrap up a few takeaways of this section as well, it will be to use complete sentences with full meaning. Do not embed requirements in section titles. Also use explicit table or figure references. And lastly, as I was mentioning for part number generation, contain the logic in the table if possible, and specify that logic and make it super simple and consistent in the cases in which it is, so that we can auto-generate that information and those part numbers.
Okay, let me just unmute here. Great. So in summary, like I said at the beginning, you really need to stop thinking about standards as documents and start thinking about the parts of standards being broken out into a database. The standards need to stand on their own as much as possible, and the components of the standard need to stand on their own. By components, I mean the requirements, the tables, the figures, making sure that they can be interpreted when they are broken out and separated outside of the context of your overall document. The biggest thing that I think is impacting how we need to change how we're writing standards that are going to be digitized is really how they're going to be used. They need to be searchable in a way that standards, you really haven't been able to search for them before. If you wanted to find a standard part before, if you wanted to find a standard material to meet your design, it wasn't always easy to do that. And now, you know, the ability to be able to search for those things, those parts and materials by composition, by properties such as tensile strength or heat resistance or things like that, that's a huge benefit of using digital standards and reducing your company's costs when you are doing product design so that you're leveraging as much standard parts and materials as possible and not having custom parts built when you don't need to. So understanding those use cases and how the data is going to be interpreted really will help you understand better why standards will need to be written differently in the future. And, you know, as I mentioned before, major theme of this presentation is consistency. Every time you have inconsistent units of measure, inconsistent references to properties, inconsistent ways you document data ranges and such, all those things will make your model that you use to have the machine read the standard and interpret the standard more complicated. And the more complicated it is, the more you may have to manually enter data into your database as opposed to extracting it using an AI model. You may need more review. One thing that we found at SAE is we have 2 separate engineers review the output of every single standard we digitize. That's a lot of overhead. I'd love to get to the point where one day we only have one engineer per standard review, or, oh my goodness, it'd be awesome if we had no manual review whatsoever. But, when you don't have standards already in a format that makes them easy to digitize, there's just too many opportunities for error. So you have to make sure that those were interpreted correctly by your machine learning algorithm if you have a lot of inconsistencies. And it also adds cost. We're having to pay engineers to review each of these. So, the cost of manual entry, the cost of managing these mapping tables, the cost of updating your natural language processing model so that it handles these additional inconsistencies as you find them, the cost of the manual review, all that adds up. And so it can be a lot more costly to digitize your standards if you don't really set yourself up for success to start with. So I also wanted to touch on, we've given you a lot of examples here. How do you really implement these? How do you make these actionable? So one thing that SAE is going to be doing is we're going to document a standard with all these best practices in it that we'll make available to you. So we'll have it laid out of what these are and in the context of each thing that we're talking about. So you'll be able to see, have a document to refer to. You can also leverage central templates or style guides at your organization to enforce some of these standards. If you want a template for a material standard, have that table, that composition table, be part of that template and how it should be. So that it's easier to interpret. So that is another way that you can try to enforce consistency and improve the digital readiness of your standards. A central editorial review is another way that you can try to enforce these styles and this framework. I mean, realistically, this is really like you're creating a style guide for standards that you want to have digitized. So having that central editorial review, having those templates and style guides will help enforce that. You can also look into creating software that will check certain things with your standards before you run them through a natural language processing model. And that can help identify standards that might have issues before you actually try to digitize it. So you can address those before you actually go through and digitize them. At this point, I see a few questions in the chat, so I'll open it up to questions. You can enter questions in the chat. Uxue, do you have any final closing remarks before I look at some of the questions and answer some of them?
No, nothing on my side. At the end, try to be consistent as much as possible. Standardize the standards, I will say.
Standardize the standard.
Yeah.
So one question is, often technical documents are very specific and have their own lingo. How do you propose we handle a glossary of terms? Is it okay to use a traditional glossary abbreviation section, or is there a better recommendation? From Rahul Singh. So I think that you could approach this from a number of ways, and I think I'd like Uxue to weigh in on it also. I do think just a traditional glossary and abbreviation section would help. We have found, though, that, with abbreviations, you do want to be careful that you use it consistently throughout. Don't have a mixture of it spelled out versus the abbreviation throughout. But there is some usefulness to having that documented. What are your thoughts, Uxue, on that?
Yes, so it will also depend on the purpose. So if the purpose is just for reference, I think the traditional ways are enough because we will be extracting the section and displaying that anyhow. So that reference will still be there. But if the purpose of these glossary abbreviation terms are also to be extracted and like stored in a database as granular pieces of information and reference, I will recommend them to be stored in a table so that it can be standardized and then also create that data, richer database.
Thank you. The next question is the plan for SAE to incorporate this new digital system into existing published standards? That question is from Erwin Oman. And yes, so these are lessons that we have learned after digitizing approximately 1,000 different standards. It was a mixture of materials, primarily metals, part standards that were primarily nuts and bolts. I really expect this to evolve into a series as we digitize other completely different types of standards. We're probably going to find a whole other slew of lessons learned and using natural language processing to digitize standards. So we are doing it today, and we are going to continue to do it to start identifying ways to help other people also digitize their standards. A big thing that I've talked about, especially when I'm talking to other standards development organizations, is you cannot develop an aircraft or a car, whatever you're developing. You're not just using SAE standards. You're using standards from everywhere. You might be using ASTM standards or ASME standards or IEEE standards. I mean, ultimately, all standards need to migrate into a consistent digital format if they're truly going to be useful. And the purpose of doing webinars like this is to start educating on how to get to that point where we can have common output from various digital standard systems. So I think it's very important to understand these, and that the whole industry starts changing how they write standards so that we can all move to that common format of digital standards. Another question. When will the standard you mentioned be available? Have you tried digitizing standards from other organizations than SAE? And those came from Chris Burrows. So I'm hoping to have the standard on how to write a digital ready standard, at least this first aspect. The entire standard is drafted, it's written. I need to have it go through the balloting process and so forth. I am hoping to have it ready in time for Aerotech, which is a conference that we have in March, where we will be presenting this information again. And I'd like to have the standard available by then, if not before then. So I'm working through that. I'm working with the person who's in charge of all SAE committees right now to find the right committee to help push this standard through and have it be official. And yes, we have tried digitizing standards from other organizations. We've digitized some from other standards development organizations, as well as we've digitized some customer standards so that we can test how well our model works on different types of standards, across. It's not just a SAE standard model. It will hopefully, we're striving to have it work for any type of standard. So we have done that. We've actually reported results back to different organizations about ways that they can, specific to their standards, ways that they can help, what things that they can do in writing their standards to make them more digital ready. So that is definitely something that we've been collaborating with people on, because as I mentioned, people are, you cannot design anything using standards from just one organization. Ultimately, these have to be interoperable from regardless of who actually owns the copyright of the standard. Another question is, are there any best practices that you recommend with respect to cross-referencing standards? So I think explicitly calling out the standard number is the best way. Every standard has some kind of unique identifier. And that is probably the best way. That question came from Bryce Wallet, former colleague of mine. Hi, Bryce. But yes, I do think that that's the best way to really do that, is to reference the specific standard number. Question from Richard Porcellus. There is an ISO IEC Smart Standards program. Is the SAE approach consistent? Yes, it is. I'm actually on that Smart Standards group. There's a cross-functional group of us that meet about once a month. And they actually, ISO just released recently all of the use cases that they've identified so far for Smart Standards. And we meet every one of them so far. So, that wasn't really a surprise, because we've been staying in close contact with the other standards development organizations. I tell people, I think it's kind of interesting, because in the past, maybe we thought of other standards development organizations in a way as competitors, but now it's funny. Standards development organizations are known for getting people from what are typically competitive companies together to work towards a standard. That's what we excel in. And now the shoe's on the other foot. We're having to do the same thing with other standards development organizations. We all need to work together to have a common framework and a common output to digital standards. Another question from Jonathan Fernando. Our standards are currently in PDF format. It sounds like the first step would be to reformat our standards with these consistency recommendations. Once that has been completed, would we then convert these standards into XML? Is that the correct? I'm sorry, that question came from Lauren Bauerschmidt. I hope I pronounced that correctly. Yes, I think that is the appropriate step. You can also work to have develop a model that could take it from PDF to digital. We have chosen to go from PDF to XML to digital, and that is the steps we have taken. So that is probably the best way to do it. But like I said, you can develop a model to work directly from PDF to digital. And then from Jonathan Fernando, what is the platform technology used to implement these best practices? So I think that some of the recommendations that I give on this slide to enforce consistency and enforce standardization in your standards are probably the best ways. You can use some technology with the checking software suggestion. But I think ultimately, when we start moving to a world where we can write a standard that we can publish in multiple ways, both digital and document at the same time, there's a lot of technologies out there that we're looking at as potential options. Because I believe that there's a lot of off-the-shelf software that we could use to make things more consistent. So from that perspective, I do think that things will be available. And as we start identifying things, we'll be definitely talking about that. Right now, we're doing a lot of evaluation of various platforms. So a question from Ken Sabo. We have thousands of standards already written that will need to be changed. The committees are made of volunteers doing this on their own time. How can a SAE help with this extra workload? We are challenged with the same thing here at SAE. There's some standards that haven't been touched in 10 years or more. So there's a couple things that we can do there. Having some of the recommendations that we make here are formatting recommendations and things that we can potentially get people to help do outside of the volunteers that are on the committees. Having central editors try to reformat documents to be in a more digital ready format is another way. ultimately there's still going to be some level or some number of legacy standards that that you'll have to try to digitize in whatever format that they are today, whether that's running them through a model that can interpret them or whether it's manually entering those. Our suggestions with this are ways you can minimize that as much as possible. At SAE, some of the things that we're looking at is some of the central editors we've started implementing in our standards groups to start enforcing that. We're also looking to roll out templates along with this standard on how to, write a more digital ready standard. So those are some of the ways that we're approaching it, but also open to other ideas people have, because it's a big challenge. I think it's especially a challenge with the part standards because they are so unique, and the challenge we've faced with the inconsistent names of different dimensions in the parts is really tough. And can lead to, and that's it, but it's also one of the most important things about part standards, and the ability to be able to search for parts based on those dimensions. So another question: what is needed on the user and in the automotive and aerospace industries, for example, to take advantage of digitized standards? A simple web app. And that's from David Monfoy. So we actually have multiple options for you, David. We do offer, we have a web app that can be used to search for and to export digital standards in a CSV file. We also have an API that we can set up to integrate with different systems. I think one of the things that's heavy on my mind these days is really the output format of digital standards. Right now, our primary output format is XML, but I do think that we might need a more specific format that is more interoperable and can be read by a requirements tracking system or can be read by model-based systems engineering systems. So that's one thing that we're looking at. I think we've made a big step, but there's still steps to go as we evolve and as we learn more about digital standards. There is a webinar series on NCOSI you can look for that I did with Alexander Jackson from Anola Technologies and Saulius Pavalkis from Dassault, where we actually talk about digital standards and use examples of digital standards that have been pulled into Dassault Magic Draw to do various model-based simulations. And you can even download the MBSE package from the SAE website. And then we took it a step further and showed how you can then leverage that and reference that information as part of your overall digital twin throughout the product development lifecycle within the whole ecosystem of that you're using. In the case, it was Dassault 3DS, but it could be Siemens or the IBM ecosystem, any of those that so you can really move towards full digital product design, full digital twin of your products. Along the lines of David's question, as a standard user, how do I consume your digital standards differently? And that comes from Alton Sanders. So I think that the webinars that I spoke to definitely show how you can consume them differently. I would highly recommend you check those out. You can see how you're pulling data and from the standards and from requirements, and actually do test cases to that standards, or run various scenarios of your model through that against the requirements in that standard. And I think that that's really useful. But I do think ultimately we can't get away from the PDF altogether, at least not immediately. And that's why I think it's very important that ultimately we have the ability to publish both PDF and digital standards until we move into an entirely digital world. Okay, so we are just about at time. Thank you so much for the questions. This was great. I hope this information was useful, and we will be in touch as the standard becomes available with all of this documented in it, so that you can get some of this information and start implementing it at your organizations. Thank you very much. And thank you to Uxue. Cognistx has been such a pivotal partner, such a important part of what we're doing with this, because SAE is not an artificial intelligence company. So they have really helped us get to the next level and helped us to understand things about our standards and how we make this journey to digital standards. So thank you, everyone. Thank you, Uxue.
Thank you.